Hello, my name is Michael, and this is the first of a few video lectures I have created on the topic of solar cells. The focus of this lecture will be to answer the simple question, why should we study solar cells? The first section of this lecture will go over why we currently need and will continue to need solar cells in the future. As you are probably aware, the global human population has been growing rapidly over the past few hundred years. The graph on the right focuses in on this and gives a bit of a projection into the future. This is important because people use a lot of power, and as the global population increases, the global demand for power grows just as fast. So, we need to look at what is going to supply all of that power. This is an old projection that has been relatively accurate. While fossil fuels such as oil, coal, and natural gas are still plentiful and supply a lot of power, there is a practical limit on how fast we can economically dig them out of the ground. So while they are a large factor, fossil fuels by themselves cannot sustain the global demand for power. Therefore, we need to start looking into renewable sources of energy to help fill that gap. The current demand for power is 15 terawatts. That's 15 million watts, where a watt is just a joule of energy per second. Now, to put that into perspective, for your average 100-watt light bulb, that will be 150 billion light bulbs. There are many different sources of renewable energy. These include hydroelectric, wind, ocean, geothermal, biomass, and lastly, solar. The number on the right represents how much power we could obtain if we devote all of our resource into researching that one field. Now, while some of the other renewable energy sources put up some okay numbers, solar power is the one with by far the most potential. So, what gives solar cells so much potential? Well, first, the fuel source is the sun. You can access it from pretty much anywhere on the Earth, and it will be there for a very long time. There are no emissions or waste coming out of the solar cell, so that makes it very good for the environment in comparison to some other fuel sources such like fossil fuels. The cost to operating is very low. In some areas without much rain, you may need to wash them, or you can, if you want, to have them tilt to track the sun, but otherwise they generate power just by sitting there. There is no heat generated from solar cells, so you don't need to worry about cooling them down. There are no moving parts, so it just doesn't just randomly break. Because of this, they are very reliable. Most manufacturers guarantee that they last at least 30 years. They have a very predictable power output on a yearly basis. You can use existing infrastructure to place them on. And as with any manufacturing, they do take some energy to make. However, solar cells generate this much energy within 1 to 2 years of being out there. So, we can conclude that solar cells are an ideal form of power that can help bridge the gap between fossil fuels and the global demand for power. In this next part of the lecture, we'll take a look at the market for solar cells. Solar power is still relatively new in the global power market, and therefore it only represents a small fraction of the amount of power generated across the world, currently less than 1%. However, the global production of solar panels has been increasing dramatically over the past few years. This graph depicts the amount of solar cells in terms of their total power capacity installed in the United States. The trend for both the past and the predicted future is that this will increase, and up to 1/3 of new electrical generation in the US will be from this solar power. There was a slight peak in 2016, and this is due to the fact that a government subsidy for solar panels was set to expire at that point, so many people tried to buy solar panels before then. One of the biggest reasons why more and more solar panels are being installed is that they are becoming cheaper to make. This graph shows that for the major solar panel manufacturers, cost of production has been decreasing with time. Note that the manufacturing cost is measured as cost divided by the power that the manufactured panels generate, and this is done in order to draw a better comparison. One last topic to touch on in regards of the use of solar panels is the balance of systems. This is just a term for all the additional infrastructure required for the use of a solar cell. This includes a power inverter to convert the direct current generated by the solar cell into alternating current, which can be fed into the power grid or used by your house, any wiring switches and fuses needed, batteries for the possible storage of electricity generated from solar cells, and lastly the frame in which the solar panel is mounted to. All of this accounts for half the cost of buying and installing solar panels.